Now HCF, factor is less than or equivalent to given number less than or equivalent to multiple. Now see here, HCF stands for highest common factor. HCF stands for highest common factor. What is this concept? Let us see it. Highest common factor. Suppose example, 6 is there, 9 is there. 6 is there, 9 is there. Let us see all the factors of 6. 1 is a factor of 6. 2 is a factor of 6. 3 is a factor of 6. 6 is a factor of 6. 1 is a factor of 6. 3 is a factor of 9. Right, 1 is a factor of 9, 3 is a factor of 9, 9 is also a factor of 9. Highest common factor. What are the factors that are common in both? 1 is common, 3 is common. But I want the highest common factor. So HCF of 6, 9 is nothing but 3. Basic definition. 6, 9, it is nothing but 3. HCF of 6, 9 is 3. What we did? We did nothing but we took a number. Right? Factor should be less than or equivalent to given number. Right? We found out all the numbers which are perfectly dividing 6. 1 will divide, 2 will divide, 3 will divide, 6 will divide. 1 will divide, 9, 3 will divide, 9 will divide. 1 is a factor common, 3 is a factor common. So HCF of 6, 9 is 3. This is a primitive level of understanding. Primitive way of understanding. Primitive way of understanding HCF. We will do one more example. Every concept, minimum 2 examples we will do. Example 2. Suppose if I take 15 and if I take 25. 15 and 25. Now what are all the factors of 15? Factors of 15 are 1 is a factor, 3 is a factor, 5 is a factor, 15 is a factor. 25. 1 is a factor, 5 is a factor, 25 is a factor. HCF of 15, 25. What are the factors common? 1 is common, 5 is common. So answer is HCF of 15, 25 is nothing but 5. I hope the idea is clear. But in the exam, we are not going to find out the factors and take common and write the answer. That's a very time consuming affair. That's a very time consuming affair. Now what we will do is, now write down key points by key points. Now write down key points. Key points are concepts. Key points. Now see, concept by concept we will go. Concept 1. First one, HCF of 10, 20, 30. HCF of 10, 20, 30. Listen carefully. Step number 1. Identify the smallest number, 10. Check whether this smallest number divides every other number. 10 will divide 20. 10 will divide 30. Yes, smallest number is the HCF. 10 will divide 20. 10 will divide 30. Few more examples. HCF of 9, 18, 36, 72. Concept 1. Take the smallest number concept. Take the smallest number concept. From basics to advanced level, I will go for it, sir. Not a single doubt you will get in my class. Take the smallest number. 9 will divide 18, 36, 72. Answer is 9. HCF of 15, 60, 120. 15, 60, 120. 15 will divide 60. 15 will divide 120. Primitive level. Answer is 15. The smallest number is dividing every other number. Smallest number is dividing every other number. If the smallest number is dividing every other number, then the number is called the HCF for a set of numbers. 10 is dividing all the other 2, 10, 9, right, 15. Concept number 1, take the smallest number concept. Take the smallest number concept. Concept number 1, it is clear. What if the smallest number does not divide? Concept 2. Concept 2. Factor of the smallest number concept. 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 HCF of 6, 9, 15. 6, 9, 15. Take the smallest number. Does 6 divide 9? No. Does 6 divide 15? No. Take the factors of 6. Come from the highest. 1, 2, 3. They are the factors of 6. Right from highest to lowest. Take the factor of 6 which is highest, 3. Check with 3. Does 3 divide 9? Yes. Does 3 divide 15? Yes. So answer is 3. Answer is 3. Second question. HCF of 15, 25, 45 and 60. 15, 25, 45 and 60. Take the smallest number. Does the smallest number divide every other number? 25 is not divisible by 15. Take the factors of 15. 1, 3, 5. These are all the factors of 6. These are all the factors of 1, 3, 5. Go from highest to lowest. 5. 5 will divide 25. 5 will divide 45. 5 will divide 60. Answer is 5. Answer is 5. Next one. HCF of 20, 30, 70. HCF of 20, 30, 70. Take the smallest number. Does 20 divide 30? No. Write down the factors. 1, 2, 5, 10. These are all the factors of 20. Come from highest to lowest. 10. Write 10. 10 2s are 20. 10 3s are 30. 10 7s are 70. Factor of the smallest number concept. I hope the idea is clear. Factor of the smallest number concept. Concept 3. Concept 3. One by one, every concept in detail we will discuss. Concept 3. Concept 3. HCF of A comma B equivalent to 1. A comma B are co-prime to each other. If two co-prime numbers are there, then their HCF is 1. A comma B are co-prime. Only one factor is common, that is 1. Only one factor is common, and that is 1. Only one factor is common, that is 1. Examples. HCF of 5 comma 7. 5 and 7 are co-prime. HCF is 1. HCF of 12 and 25. There are no factors common. 12 factors are 1, 2, 3, 4, 6, 12. 25 is 1, 5, 25. What is the factor common? Only 1. If the factor common is only 1, then the HCF of co-prime numbers is 1. Third one. HCF of 9 comma 16 comma 23. 9 comma 16 comma 23. Right? 9, 16 and 23. Factor common is 1. Factor common is 1. HCF of, what is the third concept? Co-prime concept. Two numbers are said to be co-prime if their HCF is 1. If their HCF is 1. Because the HCF is 1, the two numbers are said to be co-prime. Or if the two numbers have got only one factor common, then the numbers are said to be co-primes. All are interchangeable concept. Co-prime means factor common is 1. Factor common is 1. If the factor common is 1, HCF will be 1. If HCF is 1, then the numbers are co-prime to each other. Then the numbers are co-prime to each other. If numbers are co-prime to each other, HCF is nothing but 1. Concept 3. Concept 3. Concept 4. Concept 4. Concept 4. Make the numbers co-prime. Make the numbers co-prime and re-multiply the factor common. Make the numbers co-prime and re-multiply the factor common. Re-multiply the factor common. Make the numbers co-prime and re-multiply the factor common. What does that mean? Example. Listen carefully to every example, sir. HCF of 12, 16. 12 and 16 are not co-prime. Make them co-prime. 4 into 3, 4 into 4. 4 is common. Take out. Remaining is HCF of 3, 4. HCF of 3, 4 is 1. So 4 ones are. Answer is nothing but 4. Answer is nothing but 4. HCF of 15, 20, 35. HCF of 15, 20, 35. They are not co-prime to each other. In fact, they are all multiples of 5. Previous question, they are all multiples of 4. These are nothing but HCF of 5 into 3, 5 into 4, 5 into 7. 5 is common. 5 is common. 5 into HCF of 3, 4, 7. They are all co-prime. 5 ones are 5. They are all co-prime. 5 ones are 5. If the numbers are not co-prime to each other, make them co-prime by taking the factor common and re-multiplying at the end. And re-multiplying with the end. I hope the idea is clear. Concept number 5. Concept number 5. Every concept I am going to use it, right, in multiple problems. Concept number 5. HCF of 1 with any natural number. HCF of 1 with any natural number, it is 1. HCF of consecutive natural numbers. HCF of consecutive natural numbers. Any number it could be. All are co-prime to each other. So their HCF is 1. HCF of 1 with any natural number, it is 1. HCF of consecutive natural numbers, it is also 1. Next one. HCF of consecutive odd numbers. HCF of consecutive odd numbers, it is also 1. 1 with any natural number, HCF is 1. HCF of consecutive natural numbers, it is 1. HCF of consecutive odd numbers also, it is 1. Third point. HCF of, suppose 12, 16. Listen carefully, sir. 12 is 4 into K1. 16 is 4 into 4, K2. Both the numbers are multiples of 4. Answer, it should be a multiple of 4 if I call it as H. Multiple of H. Multiple of H. Or I will put it in simple language so that it is valid for any numbers. Please write down. HCF of A comma B equivalent to X. If A comma B are multiples of K, if A comma B are multiples of K, X also should be a multiple of K. X also should be a multiple of K. X also should be a multiple of K. See here. HCF of 15, 25. 5, 10, 12, 13. HCF of 15 comma 25, 5, 10, 12, 13. Now if you see here, listen carefully, sir. 15, 25. HCF of another important point. Odd numbers is always an odd number. HCF of odd numbers is always an odd number. HCF of even numbers is always an even number. HCF of odd numbers is an odd number. HCF of even numbers is an even number. Even numbers is an even number. HCF of odd numbers is an odd number. It cannot be even. 10 and 12. 15 is a multiple of 5. 25 is a multiple of 5. Answer should be a multiple of 5. Answer should be a multiple of 5. Suppose if it is 55, factor cannot exceed the original number. Preliminary examples. In the slides, I kept some very good questions. Every key point is extremely important, sir. HCF of 1 with any natural number is 1. HCF of consecutive natural numbers is 1. Consecutive odd numbers is also 1. If HCF of two numbers is x, if A and B are multiples of k, x also should be a multiple of k. X also should be a multiple of k. HCF of odd numbers, concept number 6. Please write down this point. HCF of A comma B. If you want the HCF of A comma B, answer is an element. Answer is an element in the set factor of B minus A. B is greater than A. Please write down. HCF of A comma B is nothing but answer is an element in the set factor of B minus A. B is greater than A. Right? Concept 6. Difference method. Concept 6. Difference method. HCF of A comma B, answer is an element in the set factor of B minus A. Please write down this. Answer is an element in the set factor of B minus A. Proof. HCF of 9 comma 12. In our school days, what we discussed, 12 is getting divided by 9. 12 is getting divided by 9. 12 is getting divided by 9. 9 ones are 9. I took the difference 3 and I checked whether 3 divides 9. 3 3s are 9, remainder is 0. If a remainder is 0, if the remainder is 0, then 3 is the HCF for these two numbers, 9 and 12. What did I do here? 12 minus 9. What is 12 minus 9? 3. So, HCF of A comma B, answer is an element in the set factor of B minus A. Factor of B minus A. HCF of 15 comma 25. 25 is getting divided by 15. 15 ones are 15. I took the difference 10. 10 ones are 10. Again it is 5. 5 twos are 10. Remainder 0. 5 is the HCF of 15 comma 25. What I said is, what we are doing it vertically, I will do it horizontally. What is horizontal concept? HCF of 9 comma 12. Answer is an element in the set factor of their difference. Factor of 12 minus 9, which is nothing but 3. What are the factors of 3? 1 and 3. Check which is the largest number which will divide the number. 1 9s are 9, 1 12s are 12. 1 will divide. 3 3s are 9, 3 4s are 12. Highest is nothing but 3. Highest is nothing but 3. What is the HCF of factor of their difference? Difference is factor of 10. What are the factors? 1, 2, 5 and 10. HCF of two odd numbers will be an odd number. 10 and 2 it is out. 5. 5 3s are 15, 5 5s are 25. So answer for this question is 5. Answer for this question is 5. Concept number 6, difference method. Concept number 6, difference method. I hope the idea is clear. Concept number 6, answer is difference method. Concept number 7. Concept number 7, minimum difference method. Minimum difference method. Not only the difference, you can also use by using minimum difference method. What is this minimum difference method? Rambabi penna jodu. Minimum difference method. Take this example. HCF of 6, 8 and 18. 6, 8 and 18. Now method 1 if I do, method 1 is HCF of 6, 8 and 18. 8 is not divisible by 6. What is the next factor of 6? 3. 8 is not divisible by 3. What is the next factor of 6? 2 will divide 8, 2 will divide 18. It is nothing but 2. Method 1. Right factor method. Method number 2. Co-prime concept if I use 2 into 3, 2 into 4, 2 into 9. 2 is common. Taken 2 common out. 2 is HCF of 3, 4 and 9. 2 into consecutive numbers HCF is 1. 1 with any number HCF is 1. 2 1s are 2. 2 1s are 2. 2 1s are 2. Method number 2. That also has given 2. Method number 1. Method number 2. Minimum difference method. This is extremely useful when we are solving some good problems, sir. Method number 3. HCF of 6 and 8 and 18. What is the minimum difference between the numbers? 6 and 8 it is 2. 6 and 18 it is 12. 8 and 18 it is 10. So minimum difference is 2. Minimum difference between the numbers is nothing but 2. Minimum difference between the numbers is nothing but 2. Take the factors of 2. 1 and 2. 1 divides every other number. 2 also divides every other number. Highest common factor is nothing but the 2. Highest common factor is nothing but 2. Highest common factor is nothing but 2. Minimum difference method. Concept number 6 is the difference method. Now it is minimum difference method. I hope the idea is clear. Minimum difference method. To make this idea clear, I will directly go back to a question, sir, so that you will understand the concept. 1 minute. Let me see where is the minimum difference method. Wonderful questions we are going to discuss today, sir. Right. See this question. HCF. Model 2. Now, HCF of 120, 150 and 135. What is the minimum difference? 120, 150 is 30. 150 minus 120. 150, 135, it is 15. 150 minus 135. Again, the third is also, it is 15. What is the other number? 135 minus 120. Minimum difference, it is nothing but 15. Minimum difference between the numbers is nothing but 15. Take the factors of 15. Factors of 15 is 1, 3, 5 and 15. 1, 3, 5 and 15. Check which one will divide the largest number. 15 8s are, 15 10s are, 15 9s are. Answer is nothing but 15. Answer is nothing but 15. minimum difference method. Find out the numbers, calculate the minimum difference between the two numbers given, or otherwise these method number 2. Method number 1, anyway we know it. What is that method? HCF of 120, 150, 135. 120 is not dividing 135. Next factor is 60. 60 is not dividing 135. 30. 35s are 30 is not dividing 135. Next is 15. 15 is dividing every other number. So answer is 15. Difference between the numbers and taking the factors, we did it. You don't need to take the difference between the numbers. You can take the minimum difference between the numbers. Next one. 56, 84, 70. Minimum difference. These 28. These 14. Here also 14. Take the minimum difference. Take the factors of 14. What are the factors of 14? 1, 2, 7 and 14. 14 4s are, 14 7s are, 14 5s are. Answer is the highest common factor. So out of this number, highest common factor is 14. Minimum difference method. Take the minimum difference between two given numbers in the set. Take the minimum difference between two given numbers in the set. Let me call it as k. Next is do the factors of k. Do the factors of k. Take the largest common factor. Take the largest common factor for k. That itself is nothing but the HCF. Minimum difference between two numbers in the set. Very interesting concept we are going to discuss. Next one. 50, 75, 125. Method number 1. HCF of 50, 75, 125. If you observe here, 50 is not dividing 75. Factor of 50, 25. 25 divides 75, 25 divides 125. Answer is 25. Answer is 25. If I take the factor of their difference, 75 minus 50 is 25. Factors of 25 are 1, 5 and 25. 25 will divide. Why we are taking the minimum difference? If you take the highest, this will be a subset among that. That will become a superset. That will become a superset. I want a subset. So answer is 25. Idea clear? HCF. HCF. Another few concepts are there. Then I will get into problem solving. Just I wanted to give a glimpse. Now see here. HCF of 362, 384, 478 and 354. Minimum difference is nothing but 8. What are the factors of 8? Factors of 8 are 1, 2, 4 and 8. 1, 2, 4 and 8. Does 8 divide any number? 8 4s are 32, 42. No. 62. What is the divisibility rule of 4? Last two digits should be divisible by 4. 62 is not divisible. All are even numbers. Definitely it is divisible by 2. Answer is 2. Answer is 2. I hope the minimum difference concept. I hope the minimum difference concept is clear to everyone. Next one. 24, 60, 48. Minimum difference is 12. So, what are the factors of minimum difference is 12? Factors of 12 are 1, 2, 3, 4, 6 and 12. 12 2s are, 12 5s are, 12 4s are. Answer is highest is 12. Highest is 12. I hope the idea is clear. I hope the idea is clear. Now let's go back. Let's go back. Let us do concept number 7 is clear. Concept number 8. If the given numbers are in prime powers, concept number 8. If the given numbers are in prime powers, if the given numbers are in prime powers, take the lowest power of the common prime basis. Take the lowest power of the common prime basis. Take the lowest power of the common prime basis. Example, n1 equivalent to 2 power 4 into 3 power 6. n2 equivalent to 2 power 8 into 3 power 3. HCF of n1 into n2. HCF of n1 comma n2. Right? Now see here, what is HCF? Lowest power of the common prime basis. 2 power 4, 2 power 8. Lowest is 2 power 4. 3 power 6, 3 power 3. Lowest is 3 power 3. Answer is 2 power 4 into 3 power 3. Another example, n equivalent to 2 power 7 into 3 power 5 into 5 power 4 into 7 square. n2 equivalent to 2 power 5 into 3 power 8 into 11 power 4. 11 power 4. HCF always takes the lowest power of the common prime basis. 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 Right? Now see here. HCF of n1 comma n2. Lowest power. 2 power 7, 2 power 5. It is 2 power 5. 3 power 5, 3 power 8. Lowest is 3 power 5. Lowest is 3 power 5. 5 power 4, nothing else is there. So there is no common. These 2 power 5 into 3 power 5. 2 power 5 into 3 power 5. I hope the idea is clear. Please, I will not ask you any questions in my class. I will teach. All you have to do it, write down in your notebook. No entertainment, no bakwas, no non-academic discussion, no wasting of your time. If the class is 90 minutes, the teacher will speak. You are a learner, learn as much as possible from my class. But gone are the days where the questions are asked like this. Now write down question. Question. HCF of A comma B, it is 12. HCF of A comma B is 12. A and B are natural numbers. A and B are natural numbers. How many values A comma B can take? You might not have seen this question anywhere else because our books are nothing but full of formulas. They don't teach you concepts. They make you by heart it. HCF of A comma B is 12. A and B are natural numbers. How many values A comma B can take? First, see this solution. Concept. HCF always takes the lowest power of the common prime basis. HCF always takes the lowest power of the common prime basis. A we don't know, B we don't know, but we know the HCF of two numbers is 12, which is 2 square into 3 power 1. Right? Harsh, please reduce your messages. Right? Reduce typing too many messages. Otherwise, the easy thing which I can do is to blog you. Right? When I am teaching, just listen. Reduce the number of messages that you are typing it. Right? Don't clutter my live chat. A and B. 12 is 2 square into 3 power 1. A is, these are nothing but the prime bases which should be present in the question. 2 power x1 into 3 power y1. 2 power x2 into 3 power y2. 2 power x2 into 3 power y2. Lowest power, minimum of x1 and x2, it is nothing but 2. Minimum of x1 and x2, it is nothing but 2. Minimum of y1 and y2 is nothing but 1. Minimum of x1 and x2, it is 2. Minimum of y1 and y2 is 1. Most of the students will solve like this. Minimum. What is the minimum? Minimum should be, minimum of x1 and x2 should be 2. So here it is 2. Am I right? So here 2 square into 3 power 1. Now what I should do is, if x1 is 0, or what I will do is, x1 should be 2. If x1 is 2, x2 can be 2, x2 can be 3, x2 can be 4, and so on. Minimum of 2 comma 2, it is nothing but 2, 2, 3, 4, and so on. Many values I am getting it. Are you all with me? Similarly, minimum of y1 and y2, it is 1. If it is 1, this will be 1, this will be 2, this will be 3, this will be 4, and so on. Now if you observe, it is 2 power 2 into 3 power 1. If the next case is 2 square into 3 power 1, or 2 cube into 3 power 1, or 2 power 4 into 3 power 1. Common between 2 square and 2 power 4 is 2 square. 3 power 1, 3 power 1 is 3 power 1. So minimum it has to be 2. Minimum it has to be 2. Minimum x is greater than or equivalent to 2. 2, 3, 4, and so on it will be. I hope you are all there with me. And so on it will be. And so on it will be. So there could be infinite number of cases that are possible. What are that infinite cases? HCF comma 12 comma 24 is 12. HCF of 36 comma 12 is 12. HCF of any multiple, right, which is giving you co-prime with 12, that will give you HCF of 12 comma 60 is 1, HCF of 1 comma 12 is 1, HCF of 12 multiple means we cannot define. So answer for this question is countably infinite. What do you mean by countably infinite? Right, you can count it, but you have better things to do in life. I hope the idea is clear. HCF of A comma B, it is nothing but 12. HCF of A comma B, it is nothing but 12. LCM of A comma B you can determine, because now see here, sir, everybody should know HCF of A comma B equivalent to 12. LCM of A comma B equivalent to 12. HCF always takes the lowest power of the common prime basis. HCF always takes the lowest power of the common prime basis. X1 greater than or equivalent to 2. It can go up to 2, 3, 4, 5, and so on up to infinite. LCM always takes the highest power of the given prime basis. HCF always, LCM always takes the highest power of the given prime basis. X1 less than or equivalent to 2. Because A and B are natural numbers, you can restrict from 1 to 2. Here there can be a finite set, but here there can be a countably infinite set. Countably infinite set. When I say x greater than or equivalent to 2, from 2 it is going further. Till where it is going further, we don't know. Are you all with me? Till where it is going further, we don't know. But here in LCM, x is less than or equivalent to 2. From 2 I am coming down. Anyway, natural number starts with 1. So I know the lowest value. But in HCF, unless and until highest value is known, right, we cannot determine. I hope you understood the difference between these two. Next one, please write down. Now with this one we will solve a lot of problems, sir. Then we will do a lot of examples when the HCF is not given. Problems based on HCF model 1. Listen carefully. HCF of 2460, 4808. Take the lowest number. Does 24 divide 16? No. Take the factor of 24. 12 5s are 60, 12 4s are 48, 12 9s are 108. Answer for this question is 12. Model number 1. Next one, HCF of 6, 12, 18. 6 will divide 12, 6 will divide 18. Answer for this question is 6. Answer for this question is 6. 8, 20, 28, 44. 8 is not dividing 20. Take 4. 4 5s are, 4 7s are, 4 11s are. Answer is nothing but 4. Answer is nothing but 4. 30, 42, 135. You can take it in any method. Method number 1. HCF of 30, 42, 135. 30. Factor is 15. 15 does not divide 42. Next it is 10. 42 is not divisible by 10. Next it is 5. 42 is not divisible by 5. Next it is 3. 3 will divide 42 and 135. So answer is 3. This is one factor method. Method 2. Common difference, minimum common difference. 30, 42. Difference is 12. Factor of 12. What are the factors of 12? 1, 2, 3, 4, 6 and 12. 1, 2, 3, 4, 6 and 12. Right, 12 is cannot divide 30. 6 5s are, 6 7s are, 6. 135 it cannot. 30 it cannot be. 3. 3 will divide every other number. So answer is highest common factor is 3. Some preliminary examples. 24, 60, 48. It is 12. So answer is nothing but 12. Already we did this question. 108, 288, 360. 108. 108 does not divide. Next is 36. 288 is 36. 8s are. 36 10s are. So the factor common is 36. The factor common is 36. I hope it is clear. Next one. 750. Now here we will discuss condensing approach. What is this condensing approach? What is this condensing approach? See here, sir. 50, 200, 300 is there. 50, 200, 300. 1 0 is common in all of this. Write down 0. Next it is 5. Does 5 divide 20? Yes. Does 5 divide 30? Yes. Write down 5. 50. So take 1 0 common. 0 common. Question became 75, 630, 189, 00. 75 cannot divide 630. 15. 15 5s are 75. Right? 15. Before that 15, 25 is there. 25, 630. No, it is not possible. Next it is 15. 15. Right? 15 4s are 60. 2s are 15. 1s are 15. 15 2s are 15. 6s are. Right answer is 15. 15 for this question. But I want for this question. Answer is 150. Answer is 150. I hope the idea is clear. Delete the factor common. 1365, 1560, 1755. Now what we will do is, you can do it in any method. Method number 1. Lowest is 1365. What are the factors of 1365? 5 2s are 10. 36. 5 7s are. 5 3s are. These nothing but 13 2s are. 13 1s are. These nothing but 3 and 7. So these are the factors. Factors is nothing but 1365. 1365 is 5 into 3 into 7 into 13. Am I right? 5 into 3 into 7 into 13. After 1365, What is the next factor? If you want the next factor, divide by the smallest number. 3 4s are 12, 16, 3 5s are 455. Does 455 divide 1560? Right, 455 into 4 is 1820. Not possible. After, if you want the next factor, divided by 5. 1365 by 5, which is 2, 5 2s are 273. 273. 5 2s are 10, 36. 5 7s are 5 3s are 273. Does 273 5s are, it is possible. 273 6 are, no, it is not possible. What is the next number? 7. 7 if you divide it. 7 1s are 7, 66. 7 9s are 63, 35. 195. Is 195 divides all these numbers? Check it out, sir. 195. 195 into 5s are 5 5s are 25. 9 5s are 45 plus 2 47. 7. It is 975. 195. 7s are 7 5s are 35, 63, 66. 1365. 7s are, it is possible. 195. 8s are 8 5s are 40, 72, 1560. 195. 9s are 5 9s are 45, 1755. So answer for this question is 195. Idea is to tell you, even though by using factorization you can move from highest to lowest. Please make a note of it, sir. 1365 factors is 5 273, 13 21s are 3 1s are 5 into 3 into 7 into 13. If you want the next number, take the number, divide by the smallest. The next number, divide by the next smallest. Divide by the next smallest. I hope the idea is clear. So answer is 195. Answer is 195. Let me get into some advanced level problems. These are all the problems. 493, 496, 406. Difference is 93. 93 is 3 into 31. 31 is 31 16s are. 403 is 31. 93 13s are. 731 is 31 2s are 62. 93. 31 is getting divided. Minimum difference method. Answer is 31.